Hi friends, welcome to our YouTube channel. Today we have to discuss about trace of a matrix. It is one of the most important concept in mathematics point of view and C programming point of view. In the previous video, we are already discussed about self-referential structure in C language. If anybody wants, please refer that video in my YouTube channel, DIVVELA SRINIVASA. Now, in this video, we have to discuss about what is trace of a matrix. Let us consider capital A is a 3 by 3 matrix that contains 3 rows and 3 columns. The first row contains 1, 2, 3. The second row contains 4, 5, 6 and the third row contains 7, 8, 9 elements. Okay, so this is a 0th row, first row, second row. This is 0th column, first column and second column. In this matrix, the matrix size is 3 by 3. That is 3 rows and 3 columns. The 3 rows are 0th row, first row, second row. 3 columns, 0th column, first column and second column. Okay. So trace of a matrix is nothing but sum of the diagonal elements of matrix A. So these are the diagonal elements of matrix A. We have to find out the sum of these diagonal elements. The first diagonal element is 1. The second diagonal element is 5. The third diagonal element is 9. So 1 plus 5 plus 9, that is equal to 15. Okay. So this diagonal element is nothing but A of 0, 0. A of 0, 0. This element. This element is A of 1, 1. And this element is A of 2, 2. How can you say that this element is diagonal element? If row value is equal to column value, then we can say that element is called as diagonal element. So here row value is 0, column value is 0. Both are same. Then this element can be taken as diagonal element. Here row value is 1, column value is 1. So that this element can be taken as diagonal element. Here row value is 2, column value is 2. Both are equal, both are equal, both are equal. Then these elements can be taken as diagonal elements. Now we can go for the definition. So trace of a matrix can be defined as sum of diagonal elements of given matrix. So this is the simple definition of trace of a matrix. Okay. Now what is the logic of trace of a matrix? Okay. So here whenever I is nothing but row, J is nothing but column. Whenever I value is equal to J, that element can be taken as diagonal elements. So for I is equal to 0, I less than size, for example 3, I plus plus. Here trace is equal to trace plus A of II. This one. Next, printf trace of matrix A is percentage D slash n double quotes n comma trace. Initially trace into trace is equal to 0. Initially trace value can be taken as 0. Okay. Now whenever I value and j value both are equal, that element can be taken as diagonal elements. Here we are taking two-dimensional array. For representing the two-dimensional array, we have to use two loops, two for loops. Okay, the first for loop represents the rows and the second for loop represents the columns. But here, while we are finding out the trace of a matrix, whenever I value equal to j value, only that element can be considered. Okay. Initially int trace is equal to 0. Okay. First, I equal to 0. Okay. So I less than 3. That means 0 less than 3. Condition true. If the condition is true, then the control goes to the body of the for loop and execute the statement within the body of the for loop. So trace is equal to trace plus a of I. So initially trace value is 0 plus a of I value is 0 and same I value is also 0. So 0 plus a of 0, 0. A of 0, 0 element is 1. So that is, so trace initially 0. So 0 plus a of 0, 0 element is 1. 0 plus 1 is equal to 1. Next, after executing the statement within the body of the for loop, then again control goes to the for loop. I value is incremented. Now I value becomes 1. Previous it is 0. Now it is 1. 1 less than 3. Condition true. If the condition is true, then the control goes to the body of the for loop and execute the statement within the body of the for loop. Trace is equal to trace. In the previous iteration, what is the trace value? 1. So 1 plus a of I value now 1. A of 1, 1. Okay. So now 1 plus a of 1, 1. What is a of 1, 1 value? So that is 5. So 1 plus 5, that is equal to 6. After executing the second iteration, trace value is equal to 6. Now again control goes to the for loop and I value is incremented. Now I value is 2. 2 less than 3. Condition true. If the condition is true, then the control goes to the body of the for loop and execute the statement within the body of the for loop. Trace is equal to trace. What is the previous iteration value? That is 6. 6 plus a of 2, 2. So what is a of 2, 2? A of 2, 2 value is 9. So 6 plus 9. So previous iteration trace value 6. Now a of 2, 2 value 9. That is 15. Okay. So after executing this statement, again control goes to the for loop and incrementing the I value. Now I value becomes 3. 3 less than 3. Condition false. If the condition is false, then the control goes to the next statement after the for loop. So after the for loop, this is the statement printf trace of matrix A is. Okay. So what is the trace value? 15. 15 is printed. So this is the output. So output is trace of matrix A is 15. 15 is printed. Okay. Here we are using for j equal to 0, j less than 3, j plus plus, trace is equal to trace plus a of jj. There is no problem at all. Either this for loop we are using ORR, and for j equal to 0, j less than 3, j plus plus, trace is equal to trace plus a of jj. That is also used. Both are correct. There is no problem at all because I equal to j. Whenever I value equal to j value, only that element can be considered. I represents rows, j represents columns. Whenever row value equal to column value, that element can be taken as diagonal elements. That elements are considered and find out the sum of those elements. So for getting the trace of matrix A. So this is the definition and this is the example and this is the logic of trace of given matrix. Now we can go for the implementation. Now we have to see the implementation of trace of a given matrix. In the previous, I am explaining the definition, logic with example. So now we have to see the implementation. First, we have to include two header files, #include stdio.h and #include conio.h. Next one, every C program execution starts with the main function. Before the main function, we have to write void. Void is an empty data type, so that main function does not return anything. So that we have to write void before the main function. Next one, here matrix A available size is row size is 10 and column size is 10. This is the available matrix A size. Next, I am taking 5 variables I, J, M, N. So I and J are the loop variables, where M represents the row size and N represents the column size. Initially, trace of a matrix is equal to 0. Next one, clear screen function. It clears the output screen. This function is available in the header file called #include conio.h. Now we are taking the required array size of matrix A. Available array size is A of 10, 10. From that available array size, we can take the required array size. For getting the required array size, so we have to use the two variables. That two variables values can be read from the keyboard by using scanf function. So scanf %d double quotes end comma ampersand m comma ampersand n, where m is the required row size and n is the required column size. Once we are reading the required row size and column size of matrix A, now we are entering the elements into matrix A. For entering the elements into matrix A, we have to use a scanf function and two for loops. The first for loop represents the rows and the second for loop represents the columns. So scanf %d double quotes and ampersand A of I of j. So we are reading 9 elements from the keyboard. That 9 elements are stored in 3 by 3 matrix. Next one, after reading the 9 elements, that 9 elements are printed in the matrix form. Okay, so this after that we have to find out the trace of a matrix. So for I is equal to 0, I less than n, I plus plus. So trace is equal to trace plus A of I. So that means we are considering the only diagonal elements. So diagonal elements is nothing but row value is equal to column value. Whenever row value is equal to column value, that element can be taken as the diagonal element. We have to find out the sum of those diagonal elements. So sum of those diagonal elements can be taken as the trace of a matrix. Finally, we are printing the trace of a matrix. So this is the program. First, we have to save that program. Next, we have to compile the program. For compiling the program, we have to use the command called Alt plus F9. We are getting 0 warnings and 0 errors. After that, press enter and running the program. For that purpose, we have to use the command called control plus F9. Now enter the size of matrix A. So I am entering row size is 3 and column size is 3. Now we are entering 9 elements into matrix A. That 9 elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 elements are entered into matrix A. That 9 elements are stored in matrix A as in this one. So the entered elements in matrix A are that 9 elements are represented in the form of matrix. So once we are representing the 9 elements in a matrix form, we are considering only diagonal elements. The diagonal elements are 1, 5, 9. Now we have to find out the sum of those diagonal elements. 1 plus 5 plus 9, that is equal to 15. The trace of a matrix A is 15. So this is the program for finding out the trace of a given matrix. So thank you for watching this video. If you like this video, please click on the like button and share this video to your friends and classmates, and please subscribe my channel name DIVVELA Srinivasa. Thank you one and all for watching this.